Okay, this is quiz number 7. Quiz 7. Sweet. So, let's see. We got this guy supporting a rigid body, and then there's a rope that wraps around it like so. It's a terrible drawing. And that's going to be dropped, and we want to find hold on, let me find it. The velocity after it has moved s distance. Cool. Okay. I think I have a different marker. So, if we have our work and energy balance, we are going to have T1 plus U as it goes from 1 to 2 equals T2. And this and this, these are the initial values of kinetic energy, and this is the work done by external forces on the system. So we can go minus T1. Neat. We know that at T1, the thing's just stationary. It's not doing anything. There's no kinetic energy. So T1 equals 0. And we know that this is essentially, much like potential energy, that is going to equal the mass times gravity times the displacement. So the external forces on the system. Yeah. Okay. What is T equal? T is equal to 1/2 mass times velocity squared plus 1/2 times the mass moment of inertia times the angular velocity. Watch out, dogs. Go away. Okay. And we know that the mass moment of inertia is equal to 1/2 mass times the radius of gyration, or we could change the k to the radius of this dude. That's fine. And omega, the angular velocity, well, we know v equals omega r, so omega is equal to velocity over the radius. And we can take those guys and we can sub it into this dude. So we'll go T is equal to 1/2 mass velocity squared plus 1/2, this guy, the mass moment of inertia. Let's go 1/2 mass times radius squared times, so this is going to square, so we'll just go v squared over r squared. And that cancels out, so we're going to have T is equal to 1/2 mass times velocity squared plus 1/4, half times a half, mass times velocity squared. We add them all up, and that is 3/4 mass velocity squared. Seems legit. Yeah, I'm not doubting that at all. Okay, so then we can take this, our u 1 to 2 equals T2 minus T1, and we can say mass times gravity times displacement is equal to 3/4 mass times velocity squared plus 0, because there's no kinetic energy initially. And from there we can divide by m, and then we'll have Shift everything over, and we have 4 over 3 times gravity times displacement is equal to v squared. So velocity will equal the square root of 4 by 3 times gravity times displacement. And there it is. That's the way to express velocity at a certain displacement point with this kind of system where the thing just drops and unrolls. Cool. Thanks for watching.